All right, so we are going to be moving into where we're talking about 3x3 augmented matrices. Technically, they're a 3x4 matrix, but we're talking about that main body of the coefficients being a 3x3. So we run into some possible solutions to the matrix. So when you have a system of equations with two variables, two equations, you can have no solution, you can have infinitely many solutions, or you can have one ordered pair. You can kind of run into something similar, but we can be more specific when we run into infinite number of solutions. So we're going to talk about what that looks like. So it says when the matrix is in the form 1, 0, 0, 1, AB, it is said to be in reduced row echelon form. The process for simplifying a matrix to reduced row echelon form is called Gauss-Jordan elimination, after our two favorite mathematicians today, called, it was Carl Friedrich Gauss and Wilhelm Jordan. The process can be used for systems of two or more variables. It is what we used last time, technically, to solve those 2x2 matrices. So just like systems of equations, sometimes there's not just one solution, like I just said. So we're going to look what happens when things are already in reduced row echelon form. So this first one, reduced row echelon form, we have that identity matrix where our diagonal, on our main diagonal, we have ones, and then everywhere else we have zeros. So that means if we were to write this back out, this means 1x plus 0y's plus 0z's equals -5. The middle row would be 0x plus 1y plus 0z equals 2, and 0x plus 0y plus 1z equals 1. Or in other words, x equals -5, y equals 2, and z equals 1. So this system has one unique solution, and it's an ordered triple of x, y, z equaling -5, 2, and 1. Okay, so if it's no solution, it's just no solution. If it has one solution, it's just an ordered triple. But then look at all these possibilities if it has infinitely many. So that's kind of what we're going to look at as we move down in the examples. So we have another possibility here. This is technically in reduced row echelon form, but we don't have zeros down that main diagonal, which means we have something funky that happened. So in the top row, we would have 1x, 0y's, minus 1z equals 2. Middle row, we have a y equaling 7. And in the bottom row, we have zeros equaling 2. Well, we have an untrue statement there in that bottom equation, which makes this one a no solution. Okay, so if you ever have like a row of all zeros, but then in your constant column, you have a constant that's not zero, you know that's a no solution. So now we're going to be looking at those infinitely manys. So when you have a row of all zeros, we have a 0 equals 0 situation, which we know is an infinite many. So now we're going to write out what each line means. So this means x plus 4z equals 4. Middle means, let's see, that's going to be y plus 3z equals 3. And then our bottom row is 0 equals 0. So if we knew what z was, we could figure out what y equaled, and we could figure out what x equaled. So we can define this function in terms of z. So if I were to solve my top equation for x, I could get x is equal to 4 minus 4z. My middle equation would become y equals 3 minus 3z. And then I could say, once I know what z equals, I'm good. So you tell me what z equals, I can solve the whole thing. So this has an infinite number of solutions. Let's see. So if we know what z equals. I can't write today. We know what x and y equal to. Okay, so we could write this as x, y, z equals, and then in place of x, we can say 4 minus 4z. In place of y, we would say 3 minus 3z, and then in z, we'd say z. Okay, so that would be our solution. So if we go back up here, so on Alex, you'd have something, again, like this. So we would pick the bottom option. We'd say, oh, this system has infinitely many solutions. And then we would pick the bottom option and fill in the x and the y. Okay, does that make sense? Hopefully. All right. Now this one is very interesting. So top row, we have x plus y equals 1. Middle row, we have z equals -3. And bottom row, we have 0 equals 0. Okay, so we have an infinite number. We know for sure z equals a number. Okay, so in the top, we could say x is equal to 1 minus y. We know z is equal to -3. So we could say x, y, z. We could say, well, if we knew what x equaled, then we could figure out, or if we knew what y equaled, then we could figure out what x equaled, and we could figure out, well, we know what z equals. So if we solve it like this equation would be 1 minus y, comma, y, comma, -3. Or if we had solved that equation differently, that top equation, if we had solved it for y, and we said y is equal to 1 minus x, once we knew what x equaled, then we could solve for y. We knew that z equals -3, then we would say x is equal to x. Right, we should probably say y is equal to y over here. Okay, so then this we could write as x, y, z is equal to x, comma, 1 minus x, comma, -3. Okay, so there's two possibilities on that one. Both are correct answers. It just depends on the way you looked at it. And if you wanted to define it in terms of x, or if you wanted to define it in terms of y. So you're going to run into some fun stuff. Good luck.